Alright guys, this will be a video on Unit 4 review, and yeah, I'm just gonna walk through all the problems, and hopefully it'll help you guys out. Let's just get started. The first three questions are all functions reviews, so I'm just going to quickly do those and not give too much explanation. So number one, we have f of x is given as x plus 1. We have g of x equals x squared plus 2x plus 3, and h of x is equal to 2. Find the following function expressions and their domains. So part A is g of x plus 1. So if we just plug x plus 1 into everywhere that x exists for g of x, we get g of x plus 1 equals x plus 1 squared plus 2x plus 1 plus 3. Just do some expansion and then combine like terms, and that's our answer. All right, then letter B is asking for g of x over f of x. Oh shoot, we do need to do domains. This domain will be all real numbers because it is a polynomial, and we have our first rational one, which we just learned in this unit. So this is going to be x plus 1 on the bottom, x squared plus 2x plus 3 on top. So just note that x can't be 1 because of our original equation right here. And then it does appear that this x plus 1 cancels, so it's going to be x plus... actually, does this x plus 1 cancel? No, it does not. So this is our final. That's our final, and our domain is going to be negative infinity to 1 u 1 infinity. All right. Then part C is going to ask us, okay, it's a large function with a lot of functions inside functions. So it's going to be like this: f of g of h of x. And the easiest way to do this is just start with the inside, in my opinion. So let's just take g of x, h of x, like this. This is going to be equal to, since we know h of x is 2, we will do 2 squared plus 2 times 2 plus 3. This equals 4 plus 4 plus 3, which equals 211. So if we know that g of h of x is 11, then we just need to find f of 11, which is going to be equal to 11 plus 1, which is 12. And obviously no domain is needed because it is a constant value. All right, moving on. Number 2, we're going to have to find... A farmer has 18 feet of fencing to build a rectangular pen for his cattle. He plans on dividing the pen in 3 equal-sized pens side by side. What dimensions will maximize this area? All right, so this was one of the questions on the other function review. So we start by drawing our thing, our diagram. We have x, 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 and x, and then we have y, y. So we have 2y plus 4x equals 1800. Divide everything by 2. Y equals 2x plus 900. Y equals 900 minus 2x. So we no longer need this y. We no longer need this y variable, so it's going to give us 900 minus 2x here. Then we have 900 minus 2x times x. So this is a of x, area. Multiply this out, we have 900x minus 2x squared. Then we have to find our negative b over 2a, which is going to equal negative 900 over negative 4, which is equal to 225. So x equals 225 for our maximum, which means 900 minus 2x is going to equal 450. So y equals 450. So our final is 225 feet by for 50 feet. And these are all we need because it's only asking for dimensions, and we do not need the area, so that is really nice. Number 3, we're gonna have to graph something. We're gonna be graphing f of x equals negative 3x squared plus 6x plus 24, and it's telling us to use zeros and the vertex. Alright, so let's get started with the zeros. We have negative 3x squared plus 6x plus 24 equals 0. Divide everything by negative 3. X squared minus 2x minus 8 equals 0. X minus 4 is going to factor, and x plus 2 will factor, and this is equal to 0. X is equal to negative 2 and 4. These are our zeros. Vertex is going to be negative b over 2a once again. And this gives us negative b, which is negative 6 over 2a, which is negative 3 times 2, which equals to 1. That means our vertex is 1, comma, and then the f of 1. So what is f of 1? F of 1 is equal to negative 3 plus 6 plus 24 is equal to positive 27. So that means our vertex is 1 comma 27, and now we can start graphing. So we do our little t right here, and this will give us negative 2 as a 0, and then 1 2 3 4 as a 0, and then we said it was going to be on 1 and then 27. So this is our vertex right here, and then graph like this, and we know it looks like a parabola. So that's all we need. All right, we're moving on to actual unit 4 stuff now, so I'm going to go down the page. 4, simplify all these expressions. Okay, so we have a, which is x to the negative 1, plus 2y, the entire thing to the negative 1. So we should have learned that negative 1 means you go on the bottom, and then negative 1 means you go on the bottom. Find a common denominator, so we multiply up, because it's going to be able to become 2y plus x over 2xy. And this is our final answer. Alright, moving on. B, 1 minus 2x over x minus 1 over x minus 1. Oops. Alright, so we'll first start by drawing our big line on top. We will try to combine this, so this is going to be x minus 2 on top. And let's try to combine the bottom with an x minus 1. So this is going to give x times x minus 1 minus 1 times x minus 1, and then minus 1. So what does this give us? This will be x minus 2 over x on top over x minus something like x minus 1 on the bottom, x squared minus x. Then it's going to be minus x plus 1 minus 1. These two cancel out at the end, which is nice. So this is going to give us x minus 2 over x. Combine some like terms, x squared minus 2x over x minus 1. And this will end up giving x minus 2 over x times, remember, dividing by a fraction means you flip it, x minus 1 over here, and then we can take out an x from here. It's x minus 2. Always look for what you can cancel. These will cancel, and this gives us x minus 1 over x squared. Nice. And it does not ask us to state domains, so we will not be doing that. Moving on, C. Oh, this is quite a big one. C is going to be one big line, and then x minus 1 over x minus 2 minus x minus 1 and then x minus 2. So it's flipped up here, like we see. We have 1 minus x minus 1. That's 1 minus x minus 2. Alright, so let's find some common denominators now. We are going to make this x minus 2 times x minus 1. On top is going to be x minus 1 squared minus x minus 2 squared. Bottom is going to be x minus 2 minus x plus 1. I'm just going to quickly take out that negative because remember, it sort of looks like, it should look like negative 1 times x minus 1, right? But then if you distribute this negative out, it's going to be minus x plus 1. And that makes our lives a little easier. And as always, the denominator stays the same. And since we're going to be doing some flipping on the bottom, this bottom part ends up going on the top when we multiply it, right? And then this top part ends up being on the bottom when we multiply it. So starting from here, we can cancel this and cancel this. So this is going to give us x minus 1 squared minus x minus 2 squared over, these x's cancel out, this plus 1 and this minus 1 right there. So then if we keep going, we're going to find that we get x squared minus 2x plus 1. We're just going to do minus parentheses x squared minus 4x plus 4. If we finally distribute, and this is all times negative 1, like this. So if we do the inside first, we have negative, these are going to cancel. This is going to become a plus, and that is plus 4x, and then a minus 2x, so it's going to be plus 2x. This is going to be minus 4 and a plus 1, so it's going to be minus 3, which ends up being negative 2x plus 3. So yeah, this whole giant expression up here simplifies down to a very simple monomial, which is really nice. And we will do d as well. D is two over a squared minus 3 over ab plus 4 over b squared. We're going to multiply everything by a squared first. So we get 2 minus 3a squared over ab plus 4a squared b squared. Multiply everything by ab. So we have 2ab minus 3a squared plus 4ab a squared. And then we're going to multiply, and this is still over b squared, my apologies. Multiply everything by b squared. So we have 2ab times b squared minus 3a squared b squared plus 4a squared ab. And this will simplify to 2ab to the third minus 3a squared b squared plus 4a to the third b. That is our answer. Alright, nice. Moving on to number 5. Number 5, I'm going to go to another page again. Simplify the expressions and state any undefined values of x. Okay, so this time we do need to state undefined values. So we have a, which is going to be 2x squared plus 3x plus 1 over x squared plus 2x plus minus 15 divided by x squared plus 6x plus 5 over 2x squared minus 7x plus 3. Okay, the very first step that we need to do is factor all of this. So the top is going to be 2x plus 1 and then x plus 1 like this. The bottom one looks to be x plus 5 and x minus 3. And then we'll do a quick flip right now. So remember, when dividing by a fraction, the top and the bottom flips. So on the bottom, it's going to be x plus 5, x plus 1. And then we're going to have on the top 2x minus 1, then x minus 3. And then remember, when we're dividing the back fraction, all values of x on top and on bottom cannot equals, the top and the bottom can't equal 0, because this original expression doesn't let us divide by 0, and once we flip it, the new expression doesn't let us divide by 0. So all of these, this one, this one, this one, and this one, when they equal 0, are not allowed, and then these two are not allowed either. So let's state our undefined values of x. X cannot be -5, 3, -1, or 1/2. All right, now we can finally do some of our simplifying. We're going to cross out this here, and cross out this here. This is going to give us 2x plus 1 times 2x minus 1 over x plus 5 squared. All right, and that is simplified enough. You don't need to expand that out. Then we have b, which is going to be even more monstrosity. We have 2x squared minus 3x minus 2 over x squared minus 1. Notice our difference of squares there. Then we have 2x squared plus 5x plus 2 over x squared plus x minus 2. Once again, let's do all of our factoring real quick, and we're going to split this into something that looks more like that, so it's easier to write out later. So we're just going to simplify the top. We have 2x times, we're going to subtract 1, I think. Yeah. No, we're going to add 1. And then x minus 2. Because remember, we're going to have -4x and then plus 1x. That's going to give us -3x. Difference of squares, we're going to bring them out. Then divide. On the bottom, we have x minus 2 plus 1. Then we're going to have 2x plus 2. No, plus 1. And 2x plus... shoot. X plus 2, like this, because you want 4x and another x. Once again, we're going to find all of our values that x cannot be. It's going to be these two and these 4. So x cannot be plus or minus 1 from these two. Then we're going to have positive 2, negative 2, so plus or minus 2 from this one and that one. And then it can't be -1/2. All right, now we have to simplify this. Let's see, we will flip it around. So if we flip it, it's going to become 2x plus 1, x minus 2 over x plus 1, x minus 2, x minus 1, my bad, times, flip it, x minus 2, and then x plus 1, and then it's 2x plus 1 on the bottom, and then x plus 2 on the bottom. All right, we can start canceling. Here and here cancels, here and here cancels, and that seems to be it. I am not sure. Let's see. Yes, that seems to be right. Okay. Oh, apologies. I did make a mistake. I was checking my work. This is x plus 2. This is x minus 1. Sorry about that. So that does mean I messed up a little bit. x plus 2, x minus 1, and then these will not end up canceling actually, so actually the 2x plus 1 still cancels, but now it's going to be this x minus 1 and x minus 1 cancel, and then these cancel out. So this actually gets some more canceling done, which is nice, and this is our final answer. Alright, moving on. Part C, x minus y minus y minus x over 1 over x squared minus 1 over y squared. Okay, first thing right off the bat, x can't equal 0. I should probably circle these from now on too, because this is important. X cannot be 0. And then let's start cross multiplying. So we have x squared minus y squared over xy over y squared minus x squared over x squared y squared. So let's do our flipping. X squared minus y squared over xy times, flip this goes to the top, xy, and I'm actually going to turn it into this form because it's slightly easier. And I would like to note that this y squared minus x squared can be written as negative x squared minus y squared, and it will help us do some canceling. This cancels out, this cancels out, this cancels out, this cancels out to xy, the negative 1 on the bottom becomes negative xy. Perfect. And the only thing, like I said, is x can't be equal 0. And, well, I guess I should say y can't equal 0 too, but it doesn't ask us for that, so it's okay. Alright, we have some more space on our page. 6. Solve the following equations for x. Alright, so a is 10 over x squared minus 2x plus 4 over x equals 5 over x minus 2. Notice that this becomes x times x minus 2. So these factors that these have, so we're going to multiply the whole equation by x squared minus 2x. It's going to be 10 plus 4 times x minus 2 equals 5 times x. X, just x. And this will give 10 plus 4x minus 8 equals 5x. Then we bring this over, so we have 2 equals x. But the thing is, this is not our solution, because it's important to note that x cannot be 0 or 2 from this front. So this is no solution. So the correct answer is no solutions, since the one that we got is not an applicable answer. Alright, moving on, number B, or section B. X over x minus 2 plus 1 over x minus 4 equals 2 over this whole polynomial of x squared minus 6x plus 8. And it's important to note that this factors into x minus 4, x minus 2. So we multiply everything by this on the bottom. We're going to get x times x minus 4 plus x minus 2, because it multiplies to the 1, equals 2. Expand it out, x squared minus 4x plus x minus 2 equals 2. We're going to move everything to one side. X squared minus 3x minus 4 equals 0. X minus 4 and x plus 1 will work, equals 0. So x equals positive 4, my bad. Plus 4 or negative 1. And let's go check our work. X cannot be 4 from this, and x cannot be equal to 2. So this 4 is not an applicable, so x just equals negative 1. Nice. Moving on. C is 10 over x plus 4, which is equal to 15 over 4 times x plus 4. Oh, x plus 1. This is unfortunate. I thought we could just get away with some easy multiplication, but nope. We're going to have to do some more work. cross multiply. So we have 4x plus 4 times 10. We go to 15 times x plus 4. So this will equal 40x plus 40 is equal to 15x plus 60. Subtract, we're going to have 25. X is equal to 20. X equals 20 over 5, 24 over 25, which is equal to 4 over 5. And this works because the only things that x can't be is x can't be negative 4 or negative 1. So this works out. Our next question is going to be solve the following inequalities. So 7. Solve the following inequalities. A, x minus 1 over 2x plus 5. This is equal to 0, less than 0, my apologies. What's our first critical point? First critical point is solving for directly, so x minus 1 is 2x plus 5 equals 0. X minus 1 equals 0, x equals 1. Or I should say that x equals 1 is our first critical point because x can't be 1, because if x were to be 1, then this value would equal 0, but it can't equal 0 because it must be less than 0. So x cannot be 1, but that is a critical point. So keep note of that. The next one is vertical asymptotes, where x can't exist in the bottom. So we have 2x plus 5 equals 0, 2x equals negative 5, x cannot be equal to negative 5 over 2. So we're just going to do that on our number line. Our first point is negative 5 over 2. And then the next one is going to be 1. So we can test a bunch of points. So what if our first point that we should probably test is like negative 3. Then we have a 0 in there and a 2. So s equals negative 3. We're going to have negative 3 minus 1 over negative 6 plus 5, which is equal to negative 4 over negative 1, which is equal to 4. And that is not less than 0. So we know that this doesn't work. What if we try 0? We're going to get negative 1 over 5, which is indeed less than 0. So we know that, I should probably mark this at 1 and 5 are both open intervals because those are places where x cannot be. And we know that it works in here. So this is a check. That doesn't work. And let's do 2. So x equals 2. We're going to get 1 over 9, which is not less than 0. This does not work either. So our final answer is going to be negative 5 over 2, open bracket, 1 open. And that is our answer. Actually, we should probably write it like this. That probably looks better. Okay. All right, so moving on, we have B, which is going to be 5t over t minus 4, which is greater than or equal to 6. Solving for directly, 5t over t minus 4 is equal to 6. 5t is equal to 6t minus 24. We have t equals 24. And since it is a greater than or equal to, t will be a closed point because it can actually equal 24. And then the other one, next critical point is t minus 4 equals 0, t equals 4. So we'll try these 3 points here. So we have 4, which is open bracket, 24, which is closed. And we will probably like try 5 or 25 and 0. 0 is always a nice one to test. All right, so let's get to testing. 0, we're going to have 0 on top, and anything on 0 is going to be 0, and 0 is obviously not greater than 6, so that's not going to work out immediately right off the bat. What about 5? It's going to give us 25 minus 1 over 1, which is greater than 6, so this middle interval works. And what about 25? We have 125 on top over 21, and if we check our calculator, this is it greater equal to 6. 125 divided by 21. It is equal to 5.95, which does not work. So this far interval doesn't work. So our answer is going to be x must be greater than 4, and it must be less than or equal to 24. And that is our interval, which is nice. All right, continuing on. From B, we have C, which is equal to 5x over, I'll factor this right away, x plus 4, x minus 2, which must be greater than 3. First two critical points, we're going to get our negative 4 and 2, because those are vertical asymptotes. Solve for this directly. 5x is equal to 3 times x squared plus 2x minus 8 from our original thing. 5x equals to 3x squared. This is a 2 plus 6x minus 24. And this will give 3x squared plus x minus 24 equals 0. And if we do our factoring, this will give us 3x. We want a minus, so the signs will be opposites. And one is slightly bigger than the other. Let's think about this. Will 4 and 6 work? No. 3 and 8 work? No. Alright, this cannot be factored. Alright. So, what do we do when we can't factor? Quadratic equation. It always works. So, x is equal to negative b, so it's negative 1, plus or minus square root of 1 minus 4 times ac over 2a. So x is going to equal using a calculator in that radical, it's 1 minus 4. Oh, I should probably note that this c is negative. That will help us. Times negative 24. Okay, so it's equal to 1 plus or minus 17 over 6, which is equal to negative 3 and 8 over 3. So this gives us 4 critical points that we need to test, which is 5 spots we need to test. So this will be a very long testing period, but that's how you need to get the full points. So you need to test every point. And then 8 over 3 is obviously bigger than 2, so 2 over here, and then 8 over 3. These are all going to be open intervals. Just note that real quick. So we'll try negative 5 here, negative 3.5 here, 0 at 2.5 here works, and we'll do 4. Alright. So negative 5, if x were equal to negative 5, it's going to be equal to negative 25 over negative 1 times negative 7, and this is not greater than 3. As you can see, it'll obviously be a negative number, so this does not work. Okay, so then what about negative 3.5 times 5 over positive 0.5 times negative 1.5? Yeah, negative 5.5. And let's calculate this out. Negative 3.5 times 5 over 0.5 times 5.5 is equal to 6.63. 6.36. My apologies. And this works. So we have our interval here that works. Let's try 0. 0 is obviously not greater than 3, so this interval in here doesn't work. 2.5. 5 times 2.5 over 6.5 times 0.5. This is equal to minus 2.5 over 6.5 times 0.5. This is 3.84, which works. All right, and let's try 4. So 5 times 4 over 8 times 2. This is 20 divided by 16, and this will obviously not be bigger than 3. This is 1.25, so that doesn't work. So our final answer is going to be -4 is less than x, which is less than -3, or we have 2, which is less than x, which is less than 8 over 3. And that is our final answer. I will leave D for you guys to do because that will take quite a while to do on a video, but it is quite intuitive, so you will just have to trust, and you will have to use Pythagorean, the quadratic formula for that. As well as number 8, I think all these problems are quite intuitive, so I will skip 8 for now, but if you need me, I can do 8 as well. These questions on number 8 are just regarding graphing. I'll do the questions, but I won't graph them. I'll leave the graphing to you guys to just check on Desmos. That's pretty easy to check on Desmos. And graphing is intuitive, you just plug points. Alright, so we have f of x for a is 4x over x squared minus 9. We have a horizontal asymptote at x equals 0 because the bottom is bigger. So that's our horizontal asymptote, so y equals 0. We have of 2 vertical asymptotes at x plus or minus 3. So we have VA x equals plus or minus 3. As 0 at x equals 0 from the top, and then no slant asymptotes, and no holes because nothing cancels. Then you can use that information to start graphing. Next one, f of x is equal to x squared minus 16. Notice the difference of squares, x plus 4. Then I'm going to factor this bottom out immediately, which is probably going to be x plus 4, x minus 3. These cancel, so that means we have a hole at x equals -4. Then we have, do we have a slant? We have, this becomes x squared minus 16 over x minus 3. So we do have a slant asymptote, and I will find that in a second. So no horizontal asymptote, but we do have another vertical asymptote, which is x equals 3. And zeros are x equals plus or minus 4. But actually, no, one of them doesn't exist anymore. So it's going to be just plus 4, because this minus 4 is actually a whole. There's no 0 there. Okay, once again, we have to do long division for this slant asymptote, which is quite annoying, but we shall do it anyway. So what times x is x squared? X, obviously, so we have 1 minus x squared minus 3x, which is actually plus 3x now, minus 16 over here. What times x gives us 3x? 3, so it's x plus 3 is going to be our slant asymptote. Remember, we don't have to do anything past here, so that's nice. So our slant asymptote is equal to y equals x plus 3. That's all the information you need. C is going to be f of x equals x over x plus 1 over, I'm going to factor this immediately because it helps out, x plus 3, x minus 2. So we have a vertical asymptote at x equals -3 and 2. We have a horizontal asymptote at y equals 0 because the top is smaller than the bottom. And then we're going to have no holes, and 0 is going to be x equals -1, and that's all you need. D is going to be 6x squared minus 11x minus 10 over 2x minus 5. Whenever it looks complicated like this, you want to just try to see if you can factor out the bottom. So does the top factor like this? Let's see, 2x minus 5. And then if it was 2x minus 5, we need a 3x here. And if it's minus 5, we would need a plus 2 here. And does this work out? We have -6x and then negative 15x and then positive 4x. And that does work out. So we see that these factor. So we're going to cancel out the bottom 2x minus 5. So this ends up being 3x plus 2. Obviously, there's no slant or horizontal asymptote. It's a linear function now. So the only hole is going to be at x equals 5 over 2. Perfect. And that's it with the front side of the page. We're going to move on to the word problems now, which is what you're probably interested in anyway. So 9, Jenna, Jana, and James can paint a room together in 2 hours. So we have them together is, okay, A plus B plus C equals 2 hours, just as a placeholder. Jana does it alone in 9 hours. Okay, so that means in 1 hour, she does 1/9 of the job. If James works alone, he can paint it in 8 hours, so he does 1/8 of the job. And we don't know what Jenna does, so she does 1/x of the job per hour. But we know that all of these equal 1 hour. Because in 1 hour you do 1/9, he does 1/9. 1 hour she does 1/9. 1 hour he does 1/8, and 1 hour she does 1/x of the room. So if we find this alone, if we multiply everything by 72x, because that is going to be our least common denominator. That is the common denominator here. Multiply everything by x and 72. So we have 8 plus 9x plus 72 equals 1. This is going to give us 17x. No, hold on. Wait a minute. If they paint the room together, it is 2. Oh, I did this wrong. I apologize. Okay, 1/9 of the room in an hour, 1/8 of the room in an hour. So if they can do the whole thing in 2 hours, they get half the thing done in 1 hour. Half the room. This is percent. This is fraction of the job. So 1/9 of the job, 1/8 of the job, 1x of the job, and all in 1 hour is 1/2 of the job in 1 hour. So if we multiply everything by 2, we're going to get 2 over 9 plus 8 over 2 plus 2 over x equals 1. Multiply everything by x, we're going to get 2. Actually, yeah, we'll do 2x. Now from here, we will multiply everything by 72, which will be quite the pain. So from here, we're going to get, actually, let's just multiply everything by 9 first. So we get 2 plus 18 over 8 plus 18 over x equals 1. Multiply everything by 8. We have 16 plus 18 plus 18 times 8 over x equals 1. Multiply everything by x. 16x plus 18x plus... Oh, I should be multiplying. Apologies for the helicopter in the background. I did not expect that. We're going to redo this. I don't know why my brain is just not working today. I apologize. We're gonna switch it around. We'll we know the bottom greatest common denominator. We'll put all the single values on one side. So we have one, like the constant values on one side. So we have 1/2 minus 1/8 minus 1/9. This makes our lives easier. And then find the common denominator, which is still 72. But it's easier this time. So we know this is going to be 36 minus 9 minus 8, which is equal to 1 over x equals 2. Right, equals 36 minus 9 minus 8, 19. So that means x is equal to 72 over 19 hours. But I just wanted to make sure that you guys knew that we're trying to look for x on the bottom, because remember, this is 9 hours to do the job, 8 hours to do the job, x hours to do the job. So this x represents how many hours. So we're going to do 72 over 19 hours. All right. Then we have 10, which is Stanley and Andrew are rowing a boat from town A to town B back on the Nile River. They travel upstream 3 miles and downstream 3 miles at an average speed of 5 miles per hour. If the trip takes them 4 hours, what is the average speed of the current? All right, so 4 total hours is going to equal what? Well, we know it takes them, they're traveling at 5, but they have to add the current of the river on the way up for 3 miles, because distance divided by speed is the time. So you want to remember that. Distance divided by speed, which is velocity, equals time, because d equals vt. That's a very important equation to remember, especially for physics. And then we have to add their trip on the way back. So it's 5, but they're going against the current this time. So then if we simplify this out by multiply everything by 25 minus c squared, because that's our difference of squares again, we have 4 times 25 minus c squared equals 3 times 5 minus c plus 3 times 5 plus c, which is equal to 100 minus 4c squared minus 15 equals 15 minus 3c plus 15 plus 3c. 3c's cancel out. We have 100 minus 4c squared equals 30. Divide everything by 4. Actually, we'll do the moving of stuff around. So we're going to have 70 equals 4c squared. C squared equals 70 over 4. C is equal to rad 70 over 2, which is roughly equal to, let's see, rad 70, then divide by 2, which is 4.183. So that's roughly the speed of the current. All right, then next one is 11, which is our final one. A race car driver completes 200 laps at an average speed of 180 miles per hour. So we're going to go like this. But after a small act, she completes the next 30 laps at an average speed of 30 miles per hour, and then 40 laps. All right, so she travels a total of 200 plus 30 plus 40 plus 30 laps, which is equal to 300. Okay, so she travels 300 laps. And she actually, we should probably give that a variable, 300 laps. And then for the first one, she does 200 laps in 180 plus the, because remember, we're looking for her average speed. So remember, going back to this v over dt, so v is going to be equal to distance divided by time. We have our total distance, and we have time down here because that's our distance divided by the speed. So distance divided by speed is time. So time is always going to be on the bottom, which works out nicely. Then she does 30 laps at how many? At 30 miles per hour plus 40 laps at 90. And then she does another 30 at 150. So if we find the common denominator, and that appears to be 900. Yeah, it's 900. Okay, common denominator is 900. 300 laps is going to equal 900 over 1000, because we're multiplying it by 5 for the 180, and then plus 900 again, because we're going to be multiplying 30, and then 40 becomes 400, because 90 is on the bottom is 10, and then we have our 30 becomes 180, because once again the 150 is being multiplied by 6 for this 900. So this is equal to 300 over 2,480 laps, 900, and then these will cancel out, the laps will cancel out, and this is just equal to 300 times 900 over 2,480, which is going to be 300, 900 divided by 2,480 is roughly 108.871 miles per hour. Don't forget the units at all times. And there we go. We are done with the worksheet. I'm sorry that this video took forever, but yeah, I'll put timestamps to help you guys. All right, thank you.